Last episode, we watched vectors flow layer by layer through a network. But what do those vectors mean? This time, the big idea, meaning itself, can become geometry, and once it does, you can do arithmetic on it. Imagine a giant map where every word is a pin. Cities that have something in common end up in the same neighborhood: king and queen near royalty, man and woman near people. On this map, closeness is not geography, it's meaning. That map is an embedding space. But how do we measure closeness? Not by straight line distance alone, by direction. Two arrows that point the same way are similar even if one is longer. The number that captures that is cosine similarity. Take the dot product and divide by both lengths, and you get 1 for perfectly aligned, 0 for perpendicular, -1 for opposite. Here is the magic. If the embedding really put gender along one direction and royalty along another, then king minus man removes the person, male part, and leaves royalty. Add woman back and you land near queen. In vectors, king minus man plus woman, then find the nearest pin. The answer pops out as geometry, not lookup. This is the heart of modern AI search. Word, sentence, and image embeddings all live in such spaces. When you ask a question, a retrieval system embeds it and grabs the nearest neighbors by cosine. That is exactly how vector databases and RAG pipelines feed relevant documents to a language model. Nearest neighbor retrieval is just who points most like me. Here's the whole thing in one file. We'll build tiny two-dimensional embeddings on axes for royalty and gender, measure cosine similarities, and solve the king analogy by arithmetic. We seed and lay out 5 words as points on two interpretable axes, royalty and gender. We define cosine similarity, dot product over the product of lengths. We compare king to queen and king to throne to see which the geometry calls more alike. Then we compute the analogy vector, king minus man plus woman, and search the remaining words for the nearest by cosine. The nearest word is queen with cosine 1. The analogy lands exactly just as the geometry promised. So meaning becomes direction and similarity becomes an angle. Next, we open the final stage, the math behind modern AI itself, starting with Fourier transforms, graphs, and Markov chains.